Gonna go viral.
Alright, so once again we did Rolle's theorem on Friday. Today we're doing mean value theorem. So let's knock it out of the park, alright? Two conditions that must be met in order for mean value theorem to apply. The first one is that the function must be continuous. Okay, so f of x is continuous, again on the closed interval AB. The second thing that must be true is that the function is differentiable on the open interval AB. So that's all that has to be true for mean value theorem to apply. Okay, no third special condition like in Rolle's theorem since it's a special case. Got it? So therefore mean value theorem maybe not therefore, let's put then. So if those two things are true, then mean value theorem applies. And there is a C in the open interval AB such that f prime of C is equal to f of b minus f of a over b minus a. What does that insinuate? What is that saying?
The slope of.
This is the slope of what? Slope of the tangent line should equal the slope of the secant line. And what do we call two lines that have equal slope? Parallel. Okay, so they're saying that I should have a line that is parallel to this one, but is a tangent to the curve, right? They have the same slope. Do you understand? So can we see why this one would be a special case of that? So if we go from 2,5 to 14,5, right? Here we said that it had to be continuous, it had to be differentiable, therefore, and f of a had to equal f of b, right? Then somewhere in between there was a number where the slope of the tangent line was what? 0, right? Well, mean value theorem says that somewhere in between there, the slope of the tangent line should equal the slope of the secant line between a and b. So think about it, if I drew a line right here, what would the slope of that line be? 0, so is there a tangent line that has the same slope as that one?
Yeah.
Yes, at that same C value. That's why it's a special case of the other. You understand? That's why for that one you had to force f of a to equal f of b. Good? Alright. So in short terms it would be like saying I rock is equal to what? A rock. The slope of the tangent line is equal to the slope of the secant. Papitas? So if you forget Rolle's theorem, hopefully you don't forget mean value theorem, and you can still use mean value theorem in place of Rolle's theorem. Okay? It's just a special case. Got it? Let's see, let's do a couple of examples and then that'll be it. So consider this function. The graph of that function is pictured below. Does MVT apply on the interval -1 to 5? Explain why or why not. Okay, so let's start off by checking the first thing, which is that it's continuous. So is it continuous on that interval? Yes? Or no? It is? Where is it not continuous?
At 0.
At 0. Why not at 0? Because I'd get 5 over 0, right? And then that would be what? Undefined. And what's 3 minus undefined? Undefined. Oh, okay. So, then we can say that h of x, right, is what? It's not continuous at x equals 0, which is on the closed interval negative 1 to 5. Therefore, what?
Mean value theorem, no.
Excellent. MBT does not apply. Papitas? What if I change the interval and now I say from positive 1 to 5? Now will it work? So let's go down to the graph and I'm going to mark my interval. So from positive 1 to 5, what would be the value at 1? Negative 2, and what would be the value at 5? Positive 2, right? Does MBT apply on the interval 1 to 5? Why or why not? So let's see, is it continuous on that interval?
Yeah.
Yes, so h of x is continuous on the closed interval 1 to 5. Is it differentiable?
Yeah.
Yeah. On the open interval 1 to 5. So that's all that has to be true for mean value theorem to apply. So therefore, we can say what? MBT applies. And that's all that they want to know in that first question. Okay. On the next one, they want you to describe in words, okay, graphically, what does MBT guarantee for the function on the interval from 1 to 5? Then they want you to draw it to the left. Okay, so looking at the graph, what is it telling us? Kind of already said it. What is guaranteed?
That the secant line of FA and FB is equal to the derivative of the tangent line.
Okay.
All the derivatives, just the derivative.
The
of
slope?
The derivative of h of x, which is the slope of the
So how can I write that in words? What's guaranteed? Something is guaranteed. There is a C, okay, in the open interval 1 to 5, okay, where what happens? Well, let's not use f prime of C, let's use like normal words. What does f prime of C represent?
the tangent line.
Slope of the tangent line, so then let's say like graphically, this would be where the tangent line, right? Where the tangent line is what? If I have two things that have the same slope,
Parallel
is parallel to the what? Secant line passing through what points? 1, negative 2, and 5, positive 2. So what this is saying is that if I draw a secant line through 1, negative 2, and 5, 2, I should be able to draw a tangent line that will have the same slope as that secant line, somewhere between 1 and 5. Okay, so let's try to do that ourselves using just our eyeball. Okay, so first off, draw the secant line going through those 2 points. And then using your ruler along the curve, try to draw a tangent line that will depict a line that has a slope that's the same as that one. That way you can visually see it. So I'm going to start here and I'm going, I want the slope to be the same as that one. So I want them to be parallel, right? And you're just trying to draw it as best as you can. So are you able to do that? Where does it seem to happen? Approximately. 2.5 approximately, right?
Sure.
So somewhere between 2 and 3, there should be a number. And is that number between 1 and 5? Yes. So do you see how that guarantee existed? For the other one, it was where the slope was 0, right? Because the secant line would have been the same, because this value would have been the same as where it ended, right? Or Rolle's theorem. You understand? Yes? Okay, great. So, apply MBT to find the values of C guaranteed for h of x on the interval. So, if MVT applies, what must be true? What did it say? F prime of C is equal to F of B minus F of A over B minus A. So we need to find both things. We need to find the average rate of change and the
So,
instantaneous rate of change. We don't know the C value, so we're just gonna have a formula, right? So what do you wanna find first? A rock? Okay, so let's find A rock. I'm gonna write here, if MVT applies, F prime of C should equal F of B minus F of A over B minus A. So you're telling me to find A rock first. Let's do it. You ready? Alright. So what's A rock? What's F of B? 2 minus F of A, negative 2, divided by B minus A, 5 minus 1. Does everybody see where I'm getting those values from? What would I do if I didn't have a graph? How would I find F of B and F of A?
you plug it into a function.
Plug it into the function, so let's put 1 up here. 3 minus 5 over 1, so 3 minus 5? Negative 2, okay? Plug in the 5. 3 minus 5 over 5. That's 3 minus 1, we get 2, okay? On your assignments, that's how it's gonna be. You're not gonna have a graph, so you're gonna have to figure it out manually, okay? Alright, so what do we get for A rock? That becomes plus, so we get 4 over 4, right? Which equals 1? Alright, what else do we need? We need the derivative, right? So we can find I rock. So what's my derivative? It'll probably be better if you rewrite H, right? So I'm gonna write it as 3 minus 5x to the negative 1, so that way when I find his derivative, it makes it easier. So what do we get? 5x to the negative 2, which is really 5 over x squared. Now we can do what with these two? Set them equal to each other. So we get 5 over, and I'm going to put c squared, because we're solving for c, is equal to what? To 1. I rock equals A rock. Are we okay? Am I confusing you? We're okay? Alright, so let's do it. Cross multiply. So we get c squared equals 5. And how do we finish it? Take the square root, so c equals
Positive square root of 5.
plus or minus radical 5.
But it's only
And
plus
which one
because
is it?
falls within
Only the positive one?
yeah, it
Why?
falls within the interval.
Very good, because that's the one in the interval. What would be the approximate value? So use your calculator, type it in, and what would we get? 2 point what? 236. Good. Should you round appropriately? Kindergarten stuff?
Yes, sir.
So did we draw it más o menos in the correct place?
There you go.
Hopefully, right?
That's it.
Try to look at it and make the space between the two lines the same all the way through. Railroad tracks. Got the idea?
Yeah.
Kindergarten stuff? Try the one in the back. Explain why you cannot apply mean value theorem to this one. So you already know mean value theorem doesn't apply. You gotta find out why. So first thing, is it continuous? How do you know? What would this be? What would be another way of writing this?
Cube root of x
The
squared
cube root of x squared minus 2. So the cube root function, is that continuous everywhere?
Yes.
Yes. Any odd root function is continuous everywhere. So this would be f of x is continuous on the closed interval -1 to 1. 2. Differentiability. Is it differentiable everywhere? How do I determine that? find the derivative, right? So we can check it. So what would be my derivative here? 2 over 3x to the negative 1/3, right? And we know that that gives us 2 divided by 3 cube root of x. And we know that that is what at what? Very good, which is undefined at x equals 0, so that means that f of x is not differentiable at what? X equals 0, which is in the interval. Therefore,
mean value theorem is not applied.
awesome, so write all that. So what could we say? Since f prime of x is undefined at x equals 0, right? Which is on the open interval negative 1 to 1. F of x is not differentiable on the open interval negative 1 to 1. Therefore, MVT does not